The National Electrical Code, commonly referred to as the NEC, is a comprehensive set of standards and guidelines governing the safe installation of electrical wiring and equipment. It is updated every 3 years by the National Fire Protection Association, or NFPA, with the goal of reducing electrical hazards and ensuring public safety. One important aspect of electrical safety is proper grounding, which provides a low impedance path for fault current to return to the source, thereby minimizing the risk of electric shock and fire. Grounding braids, also known as grounding straps, are flexible conductors used to connect electrical components to ground. They offer a low resistance path for fault currents and help to minimize electromagnetic interference. The NEC doesn't specifically use the term grounding braid in the way one might expect in an index. It refers to grounding conductors and bonding jumpers, which a grounding braid functionally serves as. These are critical components in ensuring electrical safety. The requirement for grounding braids or similar bonding methods for circuit breakers in new buildings came into effect in 1999. Prior to 1999, the NEC did not explicitly mandate the use of grounding braids for circuit breakers in all new construction. While good electrical practices often included grounding breakers, it was not a universal requirement enforced by the code. The 1999 NEC introduced changes that effectively required better grounding and bonding practices for electrical equipment, including circuit breakers. This was achieved through revisions and additions to sections addressing equipment grounding conductors, bonding, and the proper installation of electrical equipment. The specific sections of the NEC that addressed these changes included Article 250, which covers grounding and bonding, and other articles related to the installation of specific types of equipment. These sections were revised to emphasize the importance of a low-impedance ground fault current path and to provide more detailed requirements for achieving effective grounding and bonding. The introduction of these requirements in the 1999 NEC was driven by a growing awareness of the importance of proper grounding in preventing electrical hazards. Studies and field experience had shown that inadequate grounding could lead to elevated touch potentials, increased risk of electric shock, and equipment damage. By mandating the use of grounding braids or equivalent bonding methods, the NEC aimed to reduce these risks and improve the overall safety of electrical installations. Grounding is the process of creating a low impedance path from electrical circuits and equipment to the earth. This path allows fault currents to flow safely back to the source, tripping circuit breakers or fuses and preventing electrical shock hazards. Bonding is the process of connecting different metallic parts of an electrical system together to create an electrically conductive path. This helps to equalize the voltage potential between different parts of the system, reducing the risk of electric shock. The NEC specifies requirements for both grounding and bonding to ensure that electrical systems are installed and maintained in a safe manner. The code covers a wide range of topics related to grounding and bonding, including the types of grounding electrodes that are permitted, the size of grounding conductors, and the methods for connecting equipment to ground. The NEC requirements for grounding braids or similar bonding methods for circuit breakers are intended to ensure that the breakers are properly grounded and bonded to the electrical system. This helps to provide a low impedance path for fault currents and to minimize the risk of electric shock. Grounding braids are typically made of flexible copper or aluminum and are designed to provide a reliable electrical connection. They are often used to connect circuit breakers to the ground busbar in an electrical panel. The NEC specifies the minimum size and type of grounding conductors that must be used for different types of equipment. It also specifies the methods for connecting equipment to ground. The code requires that grounding conductors be securely fastened to the equipment and to the grounding electrode system. The grounding electrode system is the network of interconnected grounding electrodes that are used to provide a connection to the earth. The NEC specifies the types of grounding electrodes that are permitted, including ground rods, ground plates, and metal underground water pipes. The code also specifies the methods for installing grounding electrodes. The installation of grounding braids or similar bonding methods for circuit breakers is typically performed by a qualified electrician. The electrician will ensure that the grounding braid is properly sized and installed according to the NEC requirements. The electrician will also verify that the grounding system is properly connected to the grounding electrode system. Proper grounding and bonding are essential for electrical safety. By following the NEC requirements for grounding and bonding, electricians can help to ensure that electrical systems are installed and maintained in a safe manner. It's important to consult the specific edition of the NEC applicable in the jurisdiction where the electrical work is being performed, as code requirements can vary. Local amendments and interpretations may also apply. The NEC is not a design manual, but rather a set of minimum safety standards. It is the responsibility of the designer and installer to ensure that the electrical system meets all applicable requirements and is suitable for the intended application. Several key sections of the NEC are relevant to grounding and bonding. Article 250, as mentioned previously, is the primary article covering grounding and bonding requirements. It provides detailed information on grounding electrode systems, grounding conductors, equipment grounding, and bonding. Article 408 covers switchboards and panel boards, and it includes requirements for grounding and bonding these types of equipment. Article 310 covers conductors for general wiring, including the sizing and installation of grounding conductors. Other articles may also contain specific grounding and bonding requirements for specific types of equipment or installations. Firstly, grounding ensures a safe path for fault currents. When a fault occurs in an electrical system, such as a short circuit, a large amount of current can flow through unintended paths. If the equipment is not properly grounded, this fault current can flow through a person who comes into contact with the equipment, resulting in electric shock. Secondly, bonding reduces voltage differences. Bonding connects different metallic parts of an electrical system together, creating an electrically conductive path. This helps to equalize the voltage potential between different parts of the system, reducing the risk of electric shock. Thirdly, it protects equipment from damage. Proper grounding and bonding can help to protect electrical equipment from damage caused by fault currents and voltage surges. When a fault occurs, the fault current will flow through the grounding system, tripping the circuit breaker or fuse and isolating the faulty equipment. The NEC provides specific requirements for the size of grounding conductors based on the size of the overcurrent protection device protecting the circuit. This ensures that the grounding conductor is capable of safely carrying the maximum fault current that could occur. The NEC also specifies the types of materials that can be used for grounding conductors. Copper and aluminum are the most common materials used for grounding conductors, and the code provides specific requirements for the installation of each type of material. The NEC requires that all electrical equipment be properly grounded. This includes equipment such as motors, transformers, and appliances. The code also requires that all metal enclosures be grounded. The NEC provides specific requirements for the methods of grounding equipment and enclosures. These methods include using grounding conductors, bonding jumpers, and metal raceways. Grounding electrodes are used to connect the grounding system to the earth. The NEC specifies the types of grounding electrodes that are permitted, including ground rods, ground plates, and metal underground water pipes. The NEC also specifies the methods for installing grounding electrodes. Grounding and bonding are essential for electrical safety. By following the NEC requirements for grounding and bonding, electricians can help to ensure that electrical systems are installed and maintained in a safe manner. The requirements for grounding braids or similar bonding methods for circuit breakers are intended to ensure that the breakers are properly grounded and bonded to the electrical system. This helps to provide a low impedance path for fault currents and to minimize the risk of electric shock. In addition to the general requirements for grounding and bonding, the NEC also includes specific requirements for certain types of equipment and installations. For example, the NEC includes specific requirements for the grounding and bonding of swimming pools, spas, and hot tubs. The NEC also includes specific requirements for the grounding and bonding of sensitive electronic equipment. These requirements are intended to protect sensitive electronic equipment from damage caused by voltage surges and other electrical disturbances. The NEC is a complex and comprehensive document. It is important for electricians and other electrical professionals to stay up to date on the latest changes to the NEC. The NEC is updated every 3 years, and each new edition includes changes and revisions to the existing requirements. To ensure electrical safety, it is crucial to adhere to the specific edition of the NEC adopted by the local jurisdiction. Local amendments and interpretations can further refine the code requirements, making it essential to stay informed about these local variations. Effective grounding and bonding not only protect individuals from electric shock, but also contribute to the reliable operation of electrical equipment. Proper grounding and bonding minimize the risk of equipment damage due to fault currents and voltage surges, extending the lifespan of electrical equipment and reducing downtime. When evaluating grounding and bonding systems, it is important to consider the overall impedance of the grounding path. The NEC requires a low impedance ground fault current path to ensure that fault currents can quickly and safely return to the source. The impedance of the grounding path can be affected by factors such as the size and length of the grounding conductors, the quality of the connections, and the type of grounding electrode system used. It is also important to consider the potential for electromagnetic interference, or EMI, in electrical systems. EMI can cause problems with sensitive electronic equipment, and proper grounding and bonding can help to reduce EMI. The NEC includes requirements for minimizing EMI in electrical systems. The NEC isn't just a set of rules, it's a framework developed and refined over many years by experts in the electrical safety field. Adhering to its guidelines reflects a commitment to safety and professionalism in electrical work.